Okay, so this lesson is going to be an introduction to electric current. And electric current is the rate at which charges are moving. So we can very much parallel this with water current. If we look outside and we watch the river go by, we can see how much water is going by a second. If that amount of water increases, we would say that it's a bigger current or stronger current. Same idea with charge. If we have more charge going by us every second, imagine sitting in a wire and watching that charge go by. The more charge there is going by us every second, the bigger the current's going to be. And this exists anytime you have a net movement of electric charge going through a medium. Most of the time we'll specifically talk about charge moving through a wire because that's the most common example. So again, where do we find examples? Of course, charge going through a wire, where we might use something called an ammeter or an ammeter to help measure the current. Another example would be thinking about the famous experiment that Franklin did with the flag and the key, or the kite and the key, and electricity traveling through that. But we also see it in biology type examples. I have a frog here because there was a scientist one time doing an experiment with electricity, and there happened, I'm not sure the reason for this, there happened to be a frog that was going to be dissected or something like that nearby, and they found when the electrical current went near the frog, it caused the deceased frog's leg to twitch. And that was when we started to realize that our bodies have currents in them as well via the nervous system. So lots of examples of where we talk about current, not only in a physics type of setting, but also certainly in a biology setting as well. So this is the equation for current. I would encourage you to go ahead and write that down onto your formula sheet. So if you want to pause, go ahead and jot it down. But let me give you some details as to what all this means. I is the letter that we use to stand for current. So just kind of get used to that the letter I is going to be current. And over here we have a delta Q. That's the amount of charge. We call it a delta Q because the change in the amount of charge that's going past you. So it's like how many amount of charge is going by you. Remember, charge is measured in coulombs. You may remember from before that charge, we had a lowercase q when we were doing electrostatics. The reason that this is an uppercase q is we're talking about a lot of charge as opposed to just individual charges. So it's the total amount of charge. So we're just using an uppercase for that. The t here is the amount of time that you count that charge in. So you'll count how much charge divided by the time that it took for that charge to go by, and that's your answer. Time doesn't need to be measured in seconds, of course. So the unit is literally coulombs per second. So it's how many coulombs of charge has passed by you in a second. But we do have a special name for that. We often call it an amp. It's really ampere, but amp for short. So the letter is an A is what we use. So current, which the variable for current is I, the unit for current is an A. So you just kind of have to remember that current's in amps. Charge, which has a variable of Q, is a unit of C. And of course, time is fairly straightforward. So here's one example problem to take a look at. In 5 seconds, I see 15 coulombs of charge pass by. So I know that the time is 5 seconds and the charge is 15 coulombs. And the question is, what is the current? So the letter that we're looking for is capital I. So as always, we write down our equation. And I look over here, delta Q is 15, and the time was 5. That gives me a current of 3 amps. So that would be the current in this particular circuit. Now the next question says, how many electrons is that going through the bulb every minute? So I know what the current is. The current is 3 amps. But I'm trying to find how many electrons are going through, not in 5 seconds, but are going through in a minute. So the time that I'm interested in now is 60 seconds. It's not 5 anymore. I'm talking about a full minute. And what I really want to get to is how many electrons. So I need to look at how much charge is that first. So I'm going to go ahead and use my equation again. So I is again the same 3 amps. But I'm trying to figure out how much charge would that be in 60 seconds. So to get the answer, you just multiply both sides by 60. So the charge would be 180 coulombs of charge in a minute. So now the question is, well, how many electrons is that? So we've done this before. You'll recall that I wrote you an equation that said if I have n electrons and I multiply each one of those electrons by its charge, 1.6 times 10 to the negative 19 coulombs, that'll get me to the total amount of coulombs. In this case, it's a huge number. It's 180 coulombs. So to get the answer, you take 180 and divide it by 1.6 times 10 to the negative 19. So I just take that into my calculator, and I get an answer of 1.125 times 10 to the 21st. So if I was counting, that's how many electrons I would have to count in just 1 minute of this charge going through my circuit.